theorem, Pascal triangle and binomial theorem, these two concepts are applied on binomial expressions. Obviously, you can read this name as well, binomial theorem. Okay, so I'm going to begin now. I am writing few binomial expressions. A plus B raised to exponent 0, then A plus B raised to exponent 1. These are all binomial expressions. Why? Because they have two terms, A and B. And I will raise them to different exponents. A plus B raised to exponent 2, then A plus B raised to exponent 3, and A plus B raised to exponent 4. Okay, now Mahi, can you please tell me any number raised to exponent 0 gives us what?
Can you please repeat the question?
Yes, if there is any number and you're raising it to the exponent 0, then what do we get?
You would get 0 or the same number of whatever you multiplied it with. I mean,
Okay, what about 2 raised to exponent 0?
I'm not really sure about this, but I think you would get 0 again.
Okay, anybody shares, do you agree or you want to change?
Would it be 1?
Yeah, I
One.
would choose 1 too.
Yeah, so see, any number or any expression, if you raise it to exponent 0, you will always get 1, okay? In fact, even if you take an expression, A plus B, this is an expression, and you raise it to exponent 0, you get 1, okay? So this right here, A plus B raised to 0, you are going to get 1. I'm writing 1 over here. Basically, Pascal triangle and binomial theorem will give you the answers for these particular expressions. If you have a binomial expression and you keep raising it to different exponents, at first I raised it to exponent 0, then to exponent 1, then to exponent 2, 3, 4. What will be the answer that you get? This Pascal triangle will give you the answer for that. Okay, now A plus B raised to exponent 1. Okay, I'm going to write it over here. A plus B raised to exponent 1. What will be the answer to this one? Would anyone like to try? If you raise any number, let's say you have 4, and you raise it to the exponent 1, then what do we get if we raise any number to the exponent 1?
The same number?
The same number, exactly. So if you have A plus B, it will work in case of expression as well. If you have expression A plus B and you're raising it to the exponent 1, you'll get the same number, which is nothing but A plus B. Okay. Now what I'm interested is, what are the coefficients of these two terms? So Mahi, what is the coefficient of A over here?
Variables?
Yes, variable is A. What is its coefficient? Like what number is multiplied with A and what number is multiplied by B?
1.
1. So over here, I will keep writing their coefficients. So coefficient of A is 1, coefficient of B is also 1. So I'm going to write a 1 over here and a 1 over here. Next, A plus B raised to exponent 2. Now this is interesting now. A plus B raised to exponent 2. This means that A plus B is multiplied by A plus B. This is actually a very famous identity, A plus B whole square. Does anyone know the answer to this one?
It's A squared plus 2AB plus B squared.
Awesome. When you will multiply A plus B with A plus B, you're going to get A squared plus 2AB plus B squared. This is actually the concept of multiplication of two binomials. Do you see? I'm multiplying two binomial expressions. Shreyas and Mahi, do you know this identity? A plus B whole square equals A square plus 2AB plus B square.
Yes.
You know, okay. Now, Shreyas, what are the coefficients of these three terms now? Coefficient of A square, coefficient of AB, coefficient of B square.
No, I don't remember. Sorry.
No, you don't have to remember anything. You can look in this identity. What is the coefficient of this term, A square?
Wow.
Can you see this? A square plus 2AB plus B square. What is the coefficient of the first term? Like over here, Mahi said that coefficient of A was 1, coefficient of B was 1. Over here, what is the coefficient of A square?
What is it? 1.
It's 1, exactly. And what is the coefficient of this term, AB?
Is it 2?
2. Last but not the least, coefficient of B square?
So 1.
1. So we have the coefficients 1, 2, and 1. So I'm going to write it over here. Okay, for A plus B whole square, we have 1, 2, and 1. Next, A plus B whole cube. Now it will become challenging. Okay, A plus B whole cube. Does anyone know the expansion to this one? A plus B whole cube. So actually, even if you don't know, you can multiply this answer by one more A plus B. So let me.
I think I know it.
Mahi, you know it?
Yes. Yes.
What is
So
it?
it's technically like the same sort of formula that you used for AB squared. It's like A3 plus B3 plus 3AB, and then A plus B. So it's just the same thing, but you're replacing the 2 with the 3.
Yes, exactly. So even if you don't know, I will write that formula that you just said. Even if you don't know it, what you can do is you can, to get the answer for A plus B whole cube, you just need to multiply A plus B whole square by one more A plus B. So A plus B whole square is this one. So you can multiply A square plus 2AB plus B squared, this complete expression, by A plus B. So when you will do that, you will get A cube plus 3A square B plus 3AB square plus B cube. This will be the final answer for A plus B whole cube. Now, Gia, can you please tell me the coefficients of these terms?
The coefficient for A cubed is 1.
1, yes. For this term,
3,
3,
3, and 1.
and 1. So I'm going to put these coefficients over here. So we got a 1, a 3, and a 1. Okay. Now, do you guys see this triangle sort of a structure? Yes, this looks like a triangle of numbers. Now, these are not just random numbers. There is some pattern. There is some pattern. Who can crack the pattern in this triangle? Let's see if you guys can crack the pattern over here.
I think I cracked it. So since it's like a triangle, if you look at both sides, it's 1s, and then the middle number is a 2, and the bottom row, it's like a 3.
Okay, so if you have cracked the pattern, then would you be able to tell the numbers for this A plus B raised to 4? Now we don't need to do any calculations. You can just try to continue this pattern.
Okay, so 1,
1, okay,
4,
4,
4,
4.
another 4, and then
Yeah.
1.
Okay, this is Mahi. Shreyas and Gia, do you guys agree with this, or do you have any other logic that you can crack?
I say 6 in the middle.
Yeah, same. 6 in the middle because
6.
3 plus 3 equals 6.
Yes. So in the middle, we're going to get 6. Okay, now the pattern over here is, see, on the left side and on the right side, we have ones. And the middle numbers are actually, they are the sum of the top two numbers. So if you see this 2, 2 is the sum of 1 and 1. This 3 is the sum of 1 and 2. This 3 is also the sum of 2 and 1. So this number should be the sum of 1 and 3. So sum of 1 and 3 is 4. Okay, let me make some drawing over here. So this 2 we get by adding 1 and 1. This 3 we get by adding 1 and 2. This 3 we get by adding 2 and 1. This 4 we get by adding 1 and 3. This 6 we will get by adding 3 and 3. This 4 we'll get by adding 3 and 1. So this is the pattern. Now just continuing like this, we can actually keep on writing the coefficients of the terms. Okay, so if now I want to know the coefficients for a plus b raised to exponent 5, which is actually my next question that I want to give you guys. Okay, Shreyas, can you please tell me the coefficients of the terms to 5?
Which term?
Whatever will be the terms in the expansion of this a plus b raised to 5, there will be some expansion. So what will be the coefficients of those terms? You just have to, continue this triangle.
Oh, all right. So 1,
1,
1, 5, 10, 10,
10.
5, 1.
Exactly. Okay. Okay. Now I guess, so this is nothing but your Pascal's triangle, everyone. This is our Pascal's triangle. Pascal's triangle actually gives us, so Pascal's triangles, everyone, it gives us the coefficients. I hope you guys know what is a coefficient, right?
Yeah, we do.
Okay, coefficients of terms in the expansion of a binomial expression. So if you have a binomial expression and you want to expand it, then you will get some terms. Okay, I will tell you how to find out the exact terms as well. Okay, that can be found out by using binomial theorem. Pascal's triangle will give you the coefficients, and the exact terms can be found out by using binomial theorem. All right, so does anyone want to write down anything, or I can move on to the next screen? Let me know. Shall I move to the next screen?
Yeah.
Okay, great. How do we actually find out the exact terms? Again, there is a pattern that you guys need to crack. So I'm going to write the exact terms for all the expression. A plus b raised to 0 is 1. A plus b raised to 1 is nothing but a plus b. A plus b raised to 2 was a square plus 2ab plus b square. Then a plus b whole cube will be a cube plus 3a square b plus 3ab square plus b cube. A plus b raised to 4 will be a raised to 4 plus 1 plus 3, that's 4a cube b plus 6a square b square plus 1 4a b cube plus b raised to 4. Okay, see, I don't remember this entire expression. There is a pattern that I'm following, and by following that pattern, I'm able to write these terms. That is exactly I want you guys to do. So can you guys identify the pattern in these terms? See, coefficients you know now. You know how to write the coefficients, these coefficients like 1, 4, 6, 4, and 1. These coefficients you will get from Pascal's triangle. But how do we actually write these terms? Can you guys identify the pattern? Look at these expressions. I'll give you 1 minute. Let's see if you can identify the pattern over in the exact terms. Shall I tell? Okay, let me tell. Look very carefully. Let's first look at this one, a plus b whole cube. So when you will start expanding this expression, first you will write the first term a, and you will raise it to the highest power, which is 3, a raised to 3. Okay, and here there will be no b. Okay, there will be no b term. And when you will move ahead, this power of 3 will keep on reducing. So from a raised to 3, it will become a raised to 2. And then in the next term, it will become just a. And in the next term, it will disappear completely. Similarly, you can look in this expansion. First, you have a raised to 4. From 4, it became a raised to 3. Then from a raised to 3, it became a raised to 2. From a raised to 2, you're getting a raised to 1. And then here it disappeared completely. This is the pattern for A. Okay. Now for pattern of B, look at this one. First, in the first term, there will be no B. Then in the next term, there will be B raised to 1. Then in the next term, there will be B raised to 2. And in the next term, there will be B raised to 3. So power of A will keep on decreasing and power of B will keep on increasing. Look at this one. There is no B here. Then you get B raised to 1. Then you get B raised to 2. Then you get B raised to 3. And then you get B raised to 4. The highest exponent will be this one, 4. Are you guys able to follow this pattern? Yes?
Yes.
Yes? Okay, good job. Now, can you guys tell me exact terms? Can you guys expand a plus b raised to exponent 5? You know the coefficients, how to get the coefficients, and I just told you how to get the powers of a, b, and ab as well. Can you guys try this one?
I think I can try.
Yes, we all can try. Let's try.
Okay, so A5 plus 5A 4 squared 4, 5A squared 4, B plus 10A squared 3,
10a
cubed 3, plus
b. There will be
B,
b as well.
B2
Square.
plus 10A cubed
Cube. Now a will
squared.
be squared, yes. And b will be
Squared. B, B3, cube plus 5AB
5a, b raised to 4.
4 plus B raised to 5.
Awesome.
Yeah.
Mahi, that is absolutely correct. So Mahi seems to get it. Okay, Shreyas and Jia, do you agree with this answer? Or you want to change, or you? Hello? You guys agree with this answer?
Yes.
Okay, awesome. Now comes the challenging question. Let's see who can tell me who can do this one. Instead of plus, now I will write minus. I'm also changing the variables. Instead of a and b, I can take any variables. Okay, I'm doing y minus z raised to exponent 6. So it's the challenging part is that instead of addition, I am now replaced it with subtraction. So what will happen in this case? Any idea?
Can I take a guess?
Yes, please.
I think the addition sign in the equation just changes to subtraction.
So all the signs will just change to subtraction?
Not all. I'm not really sure.
Okay. Gia, what do you think?
I think the same thing, except I think that some symbols like y to the fifth power will be negative, and the even numbers like y to the sixth power will be positive.
Okay, you're almost there, almost there. Okay, Shreyas, what do you have to say? What will happen in this case?
Would some numbers be negative?
Some, yes. So some of the terms, see over here you have, okay, and did you observe one thing? When the exponent was 5, then how many terms did we have? 1, 2, 3, 4, 5, 6. When the exponent was 5, we had 6 number of terms. Let's check this. When exponent was 0, we had 1 term. When exponent is 1, then we had 2 terms. When exponent is 2, then we had 3 terms. So the number of terms is actually 1 more than the exponent, right? When exponent is 6, so we are going to have 7 terms. So that's one thing, that we are going to have 7 terms in this expansion. Now all you have to do is, just in the expansion of a plus b, in place of a, now you have a y, and in place of b, you have a negative z. If you guys know this concept, subtraction is actually addition of the additive inverse. So when you're subtracting z, that means you are adding negative z. How many, did you guys know this concept? That subtraction is actually addition of additive inverse.
Yep.
So what is
Yes.
additive inverse of z is negative z, okay? So what change has happened here? Instead of a, I have y, and instead of b, I have negative z. That is the only change, okay? So what you will do in the expansion, everything will remain same, just in place of b, we will put negative z now, okay? Let's try to expand this one. Okay, so I'm going to get, first of all, y raised to 6 plus, what will be the coefficients in this case? You will have a 6, then y raised to 5, okay, and then you will have negative z, then plus, the next coefficient will be 15. See, 5 plus 10 will give you 15. Then you will get y raised to 4 and negative z raised to 2. The power will keep on increasing for negative z. Then again, 10 plus 10 will give you 20. Y cube negative z. Now 2 will become 3. The next coefficient will be 10 plus 5, which is 15. So y square and negative z raised to 4. The next 5 plus 1, that is 6. Okay, and y and negative z raised to 5. Then next we'll get y will disappear completely and you'll get negative z raised to 6. Okay, now we are not done yet. We need to simplify these exponents. Now Gia said that when we have even exponents, like here we have even exponent, and even exponent, then we'll get a positive answer. And whenever we have a negative exponent, then we'll get a negative. This is a very normal concept. So y raised to 6. Here, this is negative z. This is an odd exponent. So we'll get minus 6y5z. This is an even exponent. So we'll get a positive term, 15y4z square. This will be negative 20y cube z cube plus 15y squared. So yeah, c4. This will be negative because exponent is odd. So minus 6y c5. And in the end, we get, this is even exponent, so plus z raised to 6. So this is the final expansion for y minus z raised to 6. And if you notice something carefully, this plus minus sign, they are changing alternately. See, first term is positive, then negative, then positive, then negative, then positive, then negative, then positive. So in case of subtraction, these signs will change alternately. Okay. Does anyone have any doubt in this question? How did we get the expansion for y minus c? Mahi, Jia, Shreyas? In any step, you guys have any doubt?